G'day again, what the? Rightio, let's check out the Barabar Caves.
A little background information. Historians are of the opinion these caves were made in the period of the Maurya Empire. The four rulers we need to know about when discussing the Barabar Caves are Chandragupta Maurya, Bindusara, Ashoka, and Ashoka's grandson, Dasharatha. Unlike Chandragupta and his son Bindusara, Ashoka, whose coronation is dated to 269 BCE, though he succeeded to the imperial throne of Magadha 3 years earlier, and his grandson Dasharatha were big fans of carving things into rock. Ashoka has numerous rock and pillar edicts attributed to him. 42 have been found so far, which lay out his idea of proper moral conduct for subjects under the Maurya Empire. While hollowing out a cave may seem like an exorbitantly time-consuming undertaking, and it likely was, it probably would have taken less time than constructing a freestanding stone temple. And these caves are small compared to temples. In this period, they were used as viharas, living quarters, for ascetics, that is, people who deny themselves pleasures and indulgences to achieve greater spirituality. The development of rock-hewn architecture was a perfect compromise between keeping ancient ascetic traditions while not yielding to the comfortable environment of a freestanding monastery. Caves also had the advantage of being less prone to vandalism, destruction from wars, and earthquake damage. They were easy to maintain and could provide shelter from heat, wild animals, and rain. And they couldn't be burnt down. All these factors probably contributed to their popularity. Note that the Sudama and Visvakarma caves were donations to a heterodox sect of Indian philosophy known as the Ajivikas. Despite converting to Buddhism, Ashoka never forced conversion of his subjects to Buddhism. This is important because his name is associated with many non-Buddhist temple donations, including these two caves. Ashoka's generous donations to other sects, despite his conversion to Buddhism, demonstrates his acceptance of all religions. This might be a good spot to stop and give you some background information on the state of knowledge of geometry in the Mauryan period. We can get an idea from the Sholba Sutras, which are part of the Vedangas. Their language is late Vedic Sanskrit, so they come from around the 1st millennium BCE, which also is the time of the Mauryan Empire. They are concerned with sacrificial altars, but geometry comes into play. We can tell from the text that the mathematicians of the time divided circles by drawing its diameters, divided rectangles by its diagonals into 4 parts equal in all respects, and divided isosceles triangles into 2 equal halves by a straight line that joins the middle point of the opposite side with the vertex. The Sholba Sutras also deal with parallelograms and the area of a square inscribed within a circle and touching the circumference. They provided rules that enable a person to construct a straight line perpendicular to another straight line, to draw a square with a given side or a rectangle with given sides, to construct a parallelogram and rectangle on the same base and within the same parallels having the same area, to draw the diagonals of a rhombus bisecting each other at right angles, to construct a quadrilateral formed by the lines joining the middle points of the sides of a rectangle, which also is a rhombus whose area is half of that of the rectangle, and to construct a square equal to the sum of 2 different squares. These sutras have knowledge of what we call the Pythagorean theorem. They show how to square a circle, that is, to construct a square using only a ruler and compass whose area is that of a given circle. They also show how to circle a square. Even today, this cannot be done exactly, but it can be done approximately. They had the concept of pi, which they approximated to 3.0885. Algebraic ideas emerge from the knowledge expressed here, too. Keep in mind that this is not a geometry textbook, it just uses geometry for a specific purpose. But it is lucid and accurate. Is it so far-fetched, then, that the people of this time could design these caves?
And a laser level to measure the caves precisely.
There are all kinds of tools and gauges that could have been used for measuring precision. I'm curious why they brought only a laser level.
The images that you are about to see are the result of the 3D scans done by our laser with a rotating beam over all the surfaces. They are the equivalent of an MRI scan. The lasers determine millions of points, allowing us to display the exact shapes recorded, with a precision close to the millimeter. We collected tri-dimensional images, which we will show you in the raw format, no touch-ups. The first one is a trapeze-shaped cave with a curved ceiling, with an entryway at the end.
Now wait, look at that. You can actually see the defects.
The second one is trapeze-shaped with a curved ceiling and an entryway at the side.
There again, notice the clear lack of precision.
The third one is entirely curved, the entryway at the end, and the back wall is also curved.
Again, note the imperfections. Surely they must have noticed this.
The fourth one is trapeze-shaped with a curved ceiling, entryway at the side, and curved at each of its extremities.
A lack of precision there again.
The fifth one is more complex. Trapeze-shaped with a curved ceiling, a conical dome cut at one end.
Imperfections. More imperfections.
Using a material harder than reinforced steel, complex shapes were built with a degree of precision ranging from 2 to 8 millimeters over a length exceeding 13 meters. This is more than good enough for the eye kind of work. These caves are almost vertically symmetrical, a real accomplishment considering the tools at the time.
Yes, it was a real accomplishment. An accuracy ranging between 2 and 8 millimeters is excellent for having done it by hand. But it's terrible if you're using advanced precision measuring tools.
So it's in this area that I think BAM has really moved the discussion forward. Patrice and his team, including geologist Eric Gunthier, who also appeared in Revelations of the Pyramids, they used modern surface roughness meters to determine just how flat and precise are some of these surfaces of worked stone.
All right, number one, surface roughness is not a measurement of flatness. So this taints everything which comes after the declarations of precision, perfect flatness measured with a surface roughness meter. You're just not using the correct tool. Here we see what was, or possibly still is, the most perfect sphere ever made. It's a sphere. It's the opposite of perfect flatness. It has a surface roughness much smoother than the best surface at the Barabar Caves. Surface roughness indicators, meters, are not tools for measuring flatness, as a thermometer is not a tool for measuring weight. So you've, again, wrong tool. You don't know the basics of what you're talking about in this. It's a furphy. This pebble I'm holding, it reflects light, but notice it also has this small pitting on it, just like the impossible precision flatness. So therefore this pebble I'm holding is precision flatness. I do declare, and as you can see, I have a pipe, so therefore I'm an authoritative source. This is just one classic example of the Dunning-Kruger effect and the lost high technology community who are illiterate in the topics that they are talking about.
Me dio tiempo a ponerme la chancla y el bañador. Voy a la playa, había subido la marea.
Down in the single digits of microns, a micron being 1,000th the part of a millimeter. If you want the imperial conversion for that, there are 25,400 microns in a single inch. And we're talking about measurements on some of these surfaces that challenge even these scales. A difference in flatness as low as 1.5 microns was measured on some of these artifacts and surfaces. For all intents and purposes, perfectly flat.
You stupid.
Create an actual precision flat surface, not the fake precision promoted by the lost high technology, but an actual precision surface. You use the Whitworth free plate technique, still the basis for that sort of precision work to this day. Polish it, and then understanding sandpaper. Now, these lost ancient high technologists want to tell you about ancient machining processes, and they don't understand the basic principles of sandpaper. And they're going to tell you about advanced in machines and what's impossible with copper and what's impossible with this. This is it's crazy town. It really is. They have no friggin' idea. It's basically sandpaper. This was 10 minutes of polishing of a flat plate, which was at a matte finish, and then I just noticed it's the angle of the light. It's not a mirror finish when observed from the front. Just like the Barabar Caves, it all has to do with a trick of light and shadow. Now, I've been running that, literally I just rubbed stones together. I filtered off, I crushed some sandstone, poured it in a jar, put in water, filtered off the water at the top to get the finer stuff. The heavier stuff sits at the bottom. I get the very fine grit, which floats in the water, poured that off to make a fine abrasive, and that's the stone you're seeing there. That's it. I went for 17 minutes. I wasn't using corundum. I was using just crushed sandstone. With there again, I'll put the links to other videos where I show you how to, because this stone originally was very rough on top. So how do you get it to flat? You rub two stones together. You want to get precision flat, you rub three stones together: A to B, B to C, C to A. It is just that simple. It's always the same spot and the same time of day to get this mirror polish reflection. Now, these are photos sourced from the internet, but let's look at the BAM one. Okay, so go to the BAM site, the builders of the ancient mysteries. Building ancient mystery. Look, I have a measuring device. Therefore, all right, so new evidence for ancient technology, for ancient precision, because I've got a measuring device. I have a pipe and a lab coat. All right, so it is just silly. So here's the clip, one of their preview clips. Can you guess where and when this glass-like mirror reflections of the Barabar Caves will be? No prizes for guessing. There it is, same location, same time of day. Well, screw me sideways. Who would have guessed that? Who would have guessed that? Okay, now, bottom left and bottom center, we see those other images, and all these other images are from BAM. And what do we have? The same thing again. Firstly, the reflection is not high quality to begin with, and it's always at the same place, same time of day, except for this one here we see on the bottom right. It's another of the Barabar Caves, same, but lower quality. All the images you see here are from BAM, and they're doing exactly the same thing. Being there and hanging around to take those photos, they would have obviously known, they do know, that this mirror reflection does not exist outside of that particular spot. This is the best that they have to offer. Again, it's an angle of the light. The camera is never shown. This cave is so heavily distorted, it is so far from flat or mirror polish precision, it is laughable that this would be presented. Well, the thing is that they cherry pick the best results and then say that this is indicative of the entire cave or the entire cave complex. This is not high quality finishing, even by primitive hand working standards. This is just not good. Now, notice again, now in the very center of the image, we see a very poor quality reflection again. Again, it's the angle of the camera, the angle of the light. just to highlight that. Didn't really come up well, but it's a cheap magician's trick. Light and angles, smoke and mirrors. That's all this is. They know this. They were hanging around at the site all day. They could have taken 1,000 mirror reflections of images of the camera, of the person behind the camera, but it's always the same location. It's always the same trick of light. They know this. Obviously they know this. They were there documenting with their surface roughness indicator, but they were not able to provide one, firstly, high quality reflection, and it's always at the same spot. This is a trick. They know this. Now, you could argue that they were sort of ignorant of this and they just sort of taken it on good faith, but they've been there. They've produced this documentary. They've spent hours and thousands of dollars traveling the world, editing, producing, promoting this particular video, but they didn't spend even a couple of hours just rubbing stones together to try and replicate this and to get that polish. 10 to 20 minutes using nothing but sand and water.
So there you go. What do you reckon? Let me know in the comments below. And remember to please like, share and subscribe. Cheers and catch you later.